Okay, this is a missing line problem. So we're given a top, a front, and a right side view. You can re-sketch these from the book, or if you want to, you can download them and print them out large to work on. I would suggest you do print it out larger. You can see the scale I'm at here. They're really small in the book. And in order to do this, you need to be able to write things on them. Unless you're just staring at it and guessing. That's not a good way to solve this problem. Okay? Because if you just stare at it and guess at it, at the solution, well, what's your backup plan? How do you check your own work? Stare at it again? Staring at it again isn't going to be how you do it. So we can use the numbering technique to to do the same thing. If you see a diagonal line, you know that's an edge view of a plane, so you can name it A. This plane is facing to the right, so in the right side view we should see the shape of this. Now we're always assuming, since there's missing lines, it's possible that you're not going to see the correct shape because there's a missing line, but it looks right, because with any inclined plane we should have, in a 3-view set, we should have an edge view and 2 contours, and we see that if we project the left side up here and the right side up here. We're expecting to see, if looking down at it, that we will be able to see plane A, the contour, and here is a contour. Same way, if we're looking at from the right side, we should see the contour A, and we see this contour, and they're similar. They're exact, except for how foreshortened they are. This is more of a vertical line than it is a horizontal line, so this horizontal plane looks a little shorter than this one. So we found that plane A. We label it in all the views. Top. What's on the top here? B. Is that a top plane or an edge between 2 planes? Does it have a depth to it? Project over here. Yes, we actually have 2 of them up here. We have a front and a back of B, which makes sense because if we project a miter line across the miter line up and over, we will have B here and B here. So those are 2 horizontal planes at the very top of the part. Well, if that's the top, then this rectangle has to be lower. So, and if we project the back and the front of C over and down, this makes sense to be C. Well, then where's C in the front view? Aha! So, what do we know about C? Well, it's on this plane. It's on this projection line, I should say. And it's going to be hidden from the front view because it's behind this piece. So it's going to be a hidden line. Okay, so we have C there, and C here. Oh, the front one is a good one to find too. D. What's this front plane? Well, here's the front plane, D. So we know it's 4 units high. Well, if it's a front plane, it's visible in the front, so there it is. We have now found every plane visible in the 3 views. Okay, so we're done. Let's try another one. Okay, problem 13. Last one was problem 24. Problem 13 from the set. And I had to darken this line up a little bit. It doesn't show up too well, that hidden line. So, let's find another plane. Here's an inclined plane. We can call it A. It is from the top to the bottom 2.5 units tall. It's visible on the right side. I don't see a line across here, so therefore we're looking for it. We know there's a missing line somewhere across here. Plane A is up here also, so this is probably plane A. There's our miter line. If you want to put the reference lines in also, you can do that. Sometimes it's good just to name your views so that your mind's eye doesn't wander and think it's a different view from another angle. So that's A. Then A must look like this, but over here rotated 90 degrees. So there's A. Found that one. What about let's see, the front here, B? What is that? Well, that would be this plane. It's 4 units high, so there's B. And it's on the very front, so there's B. It's 6 units wide, so that's the whole line. Up here we have C. This is a plane visible on the top. Must be this thing here. It's 2 units wide, so there's C. Where's the depth? Does it have depth of 4? Yes, it does. So right there is C. What else we got? The right side, D. So that would be visible as a contour in the right side view. So it probably is this thing right here. What about that one? Yeah, there's another leg over here. So this is D. That also is D. It's been cut in half, but that plane is D and D. Okay, what's that line across there? Well, that must be this piece back here. Okay, so this plane, E, what I'm doing is I'm not looking necessarily for hidden or missing lines. What I'm doing is just finding every plane, and if I do that, I will find every line. If I can identify every plane in every view. So this plane, we know the height of it, 2 units high. That would be behind D here. Actually, it's a little bit taller than D. It goes across here. So this is E. It looks like it's visible through this slot. Okay, but it's in the background behind D. And it's this rectangle here. This back edge is going to be a hidden line. It goes from the front of the part all the way to the back. So there'll be a hidden line here, like that. Okay. F. This line F is this plane, which if I project it up, must be this. It's a vertical plane facing to the right. So where's F over here? Well, there's the top of it right there. Here's the bottom of it. Is it visible on the right side? Yes, it is. So we draw that line in. And there's F. So we found A, B, C, D, E, F. All planes on all sides that we can see. Now, are there other planes? Yes, there are. I mean, there is the back plane. Where's the back plane? If we called that G, well, that's just behind B. It would be made out of hidden lines. We can't see any hidden lines except this one because they're all behind B. Okay, there's a left side view. That's this thing here, which is 3 units high from the bottom. So this plane is the left side view. This plane here is back here. So you can find planes even that are invisible or that are hidden from view, even if you can't find the hidden lines of all the sides. Okay, so we just worry about what's visible or hidden from the top, the front, and the right side. Find all the planes, you'll find all the lines. So sometimes you can work this different ways. Sometimes you might just look at it and something might pop into your head like that doesn't look right, you know, so you look for it. Look for something else. Okay, so here we have, let's work top down. If we look at the top line, we call that A. Now if that thing is like the top of an A-frame house, that's just an edge between 2 sloped sides, okay? 2 sloped sides of a house like that, like you know, I get that, like that, anyway. Or it has a depth to it. A horizontal plane is going back into the paper there. If it has a depth. So I project this feature over, and yes, it does have a depth of 4. So what we know about A is it is 6 units wide. Here's my front view. Right side, top. Let me put my reference lines in my miter line, just in case I need the tool. Okay, so A is 6 units wide, 4 units deep. Something is going on right here on A where A is changing shape. If we're drawing around the perimeter of A, right there, A is changing shape. But what we know is A is 6 wide and 4 deep. And it should be visible, of course, from the top. So we look at the top view. Do you see a contour that is 6 units wide and 4 deep? Yes, of course you do. You see this one. Now, of course, you could have a missing line sometimes, so you might be, looking for something that isn't quite there. But you make assumptions and then you check your assumptions. So that's A. It's 6 units wide, it's 4 units deep. Okay. What about the frontal plane? What about the front here? B. It's 6 units wide. Well, we do have a front that's 6 units wide, so that looks like this is B. And we look at the front over in the right side view, B. It's 4 units high, so this does maintain that it's 4 high and 6 wide, so that could possibly be B. Then we have some other planes. Well, let's look at this one, C. It's a 3-sided or triangular plane. Let's name this point 1 and this point 2. 1 and 2 are on A. They're on the top. So this is point 1, and this, also on the top, is point 2. Well, either C is a horizontal plane lower than A, in which case it would be 3 units wide, and it would have to be a line across here somewhere, which we don't have. So we have to find C. Or C is attached to this edge, and this is an edge between A and C. Let's put point 1 over here. Let's project it here and down. So that's 1, and 2 is projected over and down. There's 2. So here's 2. Okay. Well, if this line is an edge between A and C, then this plane is dipping down. It would roll, if you dropped the ball here, it would roll down C, and it would come down to point 3. Well, if that's point 3 there of ABC, then then 3 would also be down this projection line. It can't be here because that's 1, so the next point is there. If we project it to the right side view, over and down, can't be there, that's point 2. So down here is 3. That makes sense because we can project it across. Which means this is C. 1, 2, 3. So where is it in the front? Well, 1, 2, 3. A contour in all 3 views is an oblique plane. So what we have is this rectangular cube that the corner is cut off. If you see a mirror image of a feature like this, you can typically assume, I'll call it C prime, that the part is symmetrical. Okay, so that's C prime. This edge here is that hidden line. So this plane, if we called that D, there's also a D above, a mirror image of it, so you call it D and D prime. This rectangle is D and D prime. Circle it, that means it's in the background. Okay, so now we see that B is actually this shape. It's still 6 wide and 4 high though, so it still maintains its truthfulness. Okay, so we're still left off with, we got a contour here, right? Let's go E. E. What would this triangle be? Well, we have some sort of a vertical line here that looks like E will be a vertical plane. Seen from the right side, it's a triangle. A normal plane, which is a vertical plane, is a contour in one view and an edge view in 2 others. So this line here is E. Right? Here's the front of it. Here's the back of it. You project it up and over. That's how long E is. So we found all the planes. We found all the sides, all the features, or all the And now, can you draw an isometric of it? We would start off with a, let me move this up so I can draw it. And I'm just going to, without paper, I'm just going to draw it on here. Okay? So we'd start off with a isometric block, right? The top goes like this. If I darken that up. If it's a simple block like this, fairly simple, not a lot of sides, a lot of times you can just sketch it. And this comes down, and we have a cut in here, right? And then we have this triangle, like that. We have a triangle on the right side, and we have one along there. So, make sure you draw your packing box very light so it looks different than the object lines. And if that makes sense as an isometric, then you must have found it right here too. Okay. So 3 of these 6 solutions that you come up with, 3 of these, your choice of 3, you're supposed to draw 3 isometrics. Okay? Use your iso paper. It'll be easier on you though.